Hi everyone, welcome to the first practical session on longitudinal data analysis for the American Congress of Rehab Medicine. My name is Keith Lose. I'm an assistant professor at the University of Utah, and I'm presenting in this session virtually with Al Kozlowski, who's been leading the lecture sessions for this workshop. So in the video today, I want to take you through our first script file in R, in which we will run through some basics of our linear modeling. So I hope you get a sense of how the R code works. And sort of how we need to set up our data structure in order to make this code run. Al will be able to help you with this as you go. Feel free to pause and start this video and rewind it kind of as needed, but this will be up both during the workshop and after the workshop. You can always refer back to it online if you need a little assistance, figuring out how to run the code or how to make some of these things work. All right, so the first thing that we want to do is open RStudio if you haven't already. You can see that I have RStudio open, and I have the script file for practical session 1 here. If you don't already have that open, you can just go to File, Open File, navigate to the appropriate folder, and you should be able to find the script file that you want. I already have the script file for session 1 open, so I'll just go ahead and open the script file for session 2 so you can see what that looks like. And now you can see that I can actually flip back and forth between those two script files. All right, so the first thing that we're going to want to do is open the libraries that we're going to use in order to access specific functions that we want for running this code. So I'll just put my cursor anywhere on that line, and I'll hit Command Enter. On a Mac, this would be, I'll hit Control Enter. On a Mac, this would be Command Enter. And you should see down below in the console window that R actually shows us some warning messages. Now, these aren't errors, they're just warnings. So R is telling us a few things that happen as we run our code. And this is telling us about functions being masked from previous packages. And masking just means that sometimes functions in R have the same name. So if a function is masked from a previous package, that means a function with the same name from a new package has overwritten the function from a previous package. So it looks like all of our libraries opened with just warnings but no errors, so that's fine. If these packages are not already installed, you will probably have gotten some errors. So you're going to want to go ahead and install them using the code provided here, or using the packages option. You can go into this window and then click install, and then you can enter the name of the package you want to install. So for instance, ggplot2, I could install here if I hadn't already had it installed on my machine. Next, we're going to import the data into R, so we'll run the get working directory command. You can see that it's currently set to my documents folder, but that's not where my data are actually saved. So we'll pull this window over, and you can see that actually my data are in a subfolder inside the documents folder and inside of that subfolder and so on. So one of the things that I'm going to do then is actually add this file name to the path. So actually, let me bring that back. I will right-click this, say copy address as text, and then I will paste it in here. Now, one thing, given the base languages are different, I have to change the backslashes from Windows into forward slashes for R. But once I do that, I can run the set working directory command, and that should run in the console window down below, but you'll see that there's no warnings or errors. So next, I'll just run the list files command to see the data that are actually in that folder. And then I can run my read.csv command to actually import the data from the data session 1 CSV file. That will pop up in the environment window. It should show up as 720 observations for 19 variables. So we have a matrix of data that is 720 rows by 19 columns. And to get a sense of that, we can use the head function to print the first 6 rows of our data frame to the screen. So here you can see the first 6 rows for each of our 19 variables, and the text just sort of wraps in the console window. But really, this is a spreadsheet that we're looking at here. So next, we can use ggplot to run some basic visualizations. And I won't talk you through exactly what each of these steps is doing, but the idea behind ggplot is that it adds layers to a graphic in the form of geomes. And so ggplot is short for the grammar of graphics. And the idea behind that then is much like a grammar in language, we can add an and this and that, right? And with a certain number of basic functions, we can actually build data visualizations with some pretty powerful but basic aesthetics, and then add geomes, or sort of fancy bits, over the top of those aesthetics. So I will run the first three steps. So I create an object called G1, then I create an object called G2 in which I add some labels to G1, and then I create an object named G3 in which I change some of the color and other features of G2. And then finally I tell it to print G3 to the screen. And what you should get is a file or a plot that looks a lot like this, where we are looking at each person as a line, and the dots are color-coded by person. And we're looking at AIS categories and the person's data as a function of time and months. So these are the Roche-scaled FIM scores for people in the AIS grades C1 to 4, AIS grades C5 to 8, and paraplegics over time. And so this gives us a sense of what our data actually look like, and how we might want to analyze our data. So this is a great first step anytime you're embarking on a project like this. You want to see, is there data missing? Does it look linear? Does it look curvilinear? What sort of functions are suggested by the shape of the data? So the next thing that we're going to do when talking about different kinds of functions is actually look at the linear fit for each person. So again, if you want to break this code down or refer to the handout, you can see kind of what the difference is between these different steps. But for now, I'm just going to run through it and show you the next plot. And what you will see now is that rather drawing individual lines connecting the dots, what we actually have are straight lines, linear best fit lines, that again are color-coded by each person. And you'll notice that this plot is conditional based on the AIS category, but if we didn't want that, for instance, maybe we wanted to have a plot that was conditional based on the subject's gender, right, or sex, we could create that plot. So now we're looking at AIS categories, and rather than drawing lines for individual subjects, we're saying within C1 to 4, color code males versus females, and in my color scheme, because I kind of let R use its default colors, males are this sort of cyan color, and females are this sort of lightish red color. Males also have the dashed line, and females have the solid line. So this isn't statistically informative for us yet, but again, we're just kind of exploring and looking at potential relationships in the data.